Wednesday, we'll be talking about graphing and slope-intercept form. The graphing and slope-intercept form will not be on your quiz, okay? So last week's material, domain and range, function, x and y intercepts, function notation, domain and range in context, and then today and tomorrow's notes are on your quiz on Friday, just so you guys are aware. So make sure you have those notes. The lesson from Wednesday will not be on your quiz. All right, it will just be a new lesson, and then we'll also be reviewing for your quiz that day. All right, you know what slope is, hopefully, at this point, but slope is the rate of change.
Yes.
This little symbol here you may have seen on sorority or fraternity shirts. It's the delta symbol. It means a change.
Oh, I'm hungry.
So this means a change in y. You can eat in here, I don't care. And this means a change in x.
Say okay.
So that delta symbol means a change. So it's saying that to find the slope, you take the change in the y coordinates and the change in the x coordinates and you divide them. So the y is the vertical change, which is up and down. If you guys don't know what vertical is, that's up and down. And horizontal is left to right.
I think horizontal is so stretched out, and then vertical has a lot of straight lines in it.
I just got right.
The horizon thing. I heard that when I was younger too.
But horizontal
Horizon.
and then underline horizon. I was like, oh. And the straight and the up to down one is the other one.
Yeah, so that is a rise over run. So rise means up and down. Rise means up and down over a run, which is left to right. All right, so when you're ready, 1 second. Go back to that page. I'm sorry. Never mind. We'll just do it that way first. Go. Never mind. I'm wrong. Just slip. Yes. No, that was not a question you should ask. All right. So if you are given a graph, you need to find 2 points on the graph. The points need to go at an exact intersection, so there will be an exact T. So notice the horizontal and vertical line meets the oblique line, which means a slanted line, where here it does not, does it? Or here it's not exact, but there it is. Do you guys see that? So the first thing you guys need to do is find the exact points. So I'm going to use these two as my exact points.
Yes.
And we said that slope is a rise over a run. So we rise 2, which is positive. Going up is positive, down is negative. We run to the right 3, which is positive to the right, negative is to the left. We have positive 2 over 3. Can that be simplified at all? Nope. Positive over a positive is still a positive. So our slope for this one is 2/3. All right, again, we have to find 2 points. So, Connor, give me a point I can use to find my slope, an exact point. That's fine, I can take my time.
Wow.
Okay, negative 2, and then like 1.2.
Give an exact one. Try to go to exact points.
Okay,
So you
exact.
see how it's
So
meeting
this
exactly
one,
across,
yeah,
so what is that?
So negative 3 and 2.
Negative 3, comma 2. Shh, please. Stop your conversations. Okay, can somebody give me another exact point? Jana. Negative 2 comma 2 is right here. I think you mean the opposite of that. Remember x comma y. Is that what you meant? Is this one right here?
Yeah.
Okay, so remember guys, an ordered pair is x comma y. X comes before y in the alphabet. Okay, there is a lot of lines going on here. This one was pretty simple because each line meant 1, right? In this case here, though, there's 4 lines for each one. So it's counting by a quarter, right? So a quarter, half, 75, 1. You see that? So be careful when you go to count this because this right here is going down. That's 1 right there, right? Do you see that? And then it's 2, 3, 4. So that is down 4. So going down is negative, so I'm making that a negative 4. You can find the same slope using different points. So if you did this on your own already, do not erase yet. Do not erase yet. See if you got the same answer. So, question. Somebody said what? Colin, was that you that said what? Are you guys okay?
Oh, yeah.
Okay, was that you that said what? Okay, are you sure you're good?
Yeah, I just didn't know, like, why you do 4 arrows, but I figured
Do you see? Because I was trying to make sure you guys realized that that was not, each box isn't 1. Okay. Then we go to the right. 1, 2, 3, 4, 5. But to the right is positive. So our slope is a rise over run. So our rise is negative 4, our run is positive 5, and we can't simplify that. If you did it a different way and got the same answer, you're good to go. If you didn't, fix it right now, please. Otherwise, please let me know if you have any questions. Otherwise, please let me know if you have any questions on finding the slope on a graph. All right, next example. Slope. You can use any 2 points on a line as a point or as a table to find the slope. So, as long as you know that something is linear and you have 2 points, you can find the slope using the slope formula. We said that slope is rise over 1, which is a change in y over change in x. So you guys may have seen this formula last year. y2 minus y1 over x2 minus x1. So if you have 2 ordered pairs, x1 comma y1
Yes.
and x2 comma y2,
That'd be correct.
and you know that it is linear, you can use this formula. Okay, the side conversations back there. Stop, please. Okay, so you do not necessarily have to use the formula every single time, but that is an option. So one of the ways you can do this, though, is just looking at a table. So, for example, it says find the rate of change in the table at the right. The table shows a band marching over time. So if we look at this, this change is how many? How much is it from 260 to 520? Yeah. How much is it from 1 to 2? I tricked you guys. Mike, how much is it from 520 to 780? How much is it from 2 to 3?
1.
How much is it from 780 to 240? Or 1040, sorry.
260.
So, you know something is linear. You know something is linear if all the slopes are the same. So, for example, from 1 to 2, we have 260 over 1, which is just 260 feet per minute. So that's just the interval x value 2 to x value 1, or 1 to 2. The next one is from 2 to 3. X value to x value is 260 over 1. So that's 260 feet per minute. Why is it feet per minute? Can somebody explain to the class why it's feet per minute?
That's what it says on the table.
Okay, but why isn't it minutes per feet?
Because you can't go minute though yet. No, that wouldn't make sense.
Okay, that's good. I'm glad that you're thinking logically, but let's think like the mathematical reason. Why?
Because it's supposed to be y over x, and we did the other way around, maybe x over y.
Right, we know it's y over x, and y is the distance in feet, and x is the time in minutes for us. That's why it's feet per minute, because you have to do y over x. Alyssa, thank you for the math reason. Boys, you are not wrong to say that it doesn't make sense, though. That's always a good way to fall back on if you have no clue why you're doing what you're doing. Okay. Shh. The last one is from 3 to 4. Again, it's an x value to another x value. And that would be 260 over 1. So do we have a constant rate of change here?
Nope.
Why not? Why not, Mike? Why isn't it constant? They're not all the same?
No, they're all the same.
So isn't it constant then?
Oh, yeah.
Yeah. So in this case, it is a constant rate of change because they're all the same. So make sure before you do anything, you check. Because sometimes we try to trick you. We try to give you guys tables that have like 1 comma something, 5 comma something, and then 8 comma something. So they're not going by the same amount on the x's. So you guys think that it's not a constant rate of change. But you need to check each rate of change and see if they simplify all the time. Okay? So be very careful with that. Questions on finding slope from a table? Okay, then let's do some more examples here. So find the slope using points. So let's just start with the points. If you're given points, I know some of you like to stack the points on top of each other and find it that way. But let's determine why that's the case first. So we know it's a rise over a run. So slope is y2 minus y1 over x2 minus x1. So you guys know which ones are which there. I fill both of them up so I don't have to go get water again during the day. All right, so tell me what would be on top of this equation. What would be the top part, Jordan? -2 minus 0. Very good. y2 minus y1. And what would be on the bottom, RC? But why? But why? RC, what would be the next one? So we did y2 minus y1. So it's x2 minus x1 down here. So what's x2?
3.
Minus. It's not 3 minus 1. It's 3 minus a -1. So that is the bottom. So I'm just color coding it there. Minus a negative becomes a positive. So we have -2 over 3 plus 1. -2 over 4, which simplifies 2. Okay, so that's one way of doing it. Some of you guys do it this way. Shh. Okay. Some of you guys like to stack it, so you'll do it this way instead. And this is why you can do what you're doing. So the change from 0 to -2 is subtracting 2. From -3 to 4 is adding, or -1 to 3 is adding 4, right? Y over x. So that is -2 over 4. Does that still give you the same answer?
Yep.
So I do not care how you want to look at that. That might be easier for some of you guys that can't do minus and negative correctly. Okay? Right. In this table here, we can just do our slope here. From 10 to 25 is 15. From -1 to 0, Justin Powers is what? Good. No, you were right. You're adding 1. Jayla, from 25 to 40 is? From 0 to 1 is? What, Cassie?
1.
So if we do both of those, from -1 to 0 is 15 over 1, which is just 15. And from 0 to 1 is 15 over 1, which is still 15. So this is a linear slope. Has a slope of 15. Yes, Kaylee.
Do you do that all the time, like on homework?
If you can, you can do it in your head and make sure you're making sure a lot, but make sure you check it. Okay? It can be in your head to check it. I'm gonna show it on the notes as showing it the whole way, but you need to check to make sure that it's simplifying to the same thing. Because we'll show an example on the next one that doesn't look like it's linear, but it actually is. So you guys can see that. So the next one on the table there does not look linear. So a lot of you guys will tell me that this is not linear. But if you're looking here, from 5 to 9, Riley, is how many?
4.
You add 4. And Brian, from 2 to -1 is what? No, if you're at 2 on a number line, don't tell him the answer. If you're at 2 on the number line and you go to -1, how many are you going to get there? Yeah, and then if you're going to the left, that makes it negative. Yeah. So that's -3 there. Okay, Tanari, from 9 to 17 is? And Miguel, how about from -1 to 7?
Subtract 6.
Good. So looking at this, you guys might tell me that it is not linear. But if you go to check it, and you check from -1 to 2, I should do that in purple. You do y over x, and you get +4 over -3, right? That doesn't simplify, so that's good. And you do -7 to -1, which is +8 over -6. What goes into both of those? 2. So if I do that, that's 4 over -3. Do you get the same number then? So you get a -4/3 slope. So do you see kind of why I say that it's good to check it? Because you guys will look at some of them and be like, oh no, that's not right. But in actuality, after you simplify it, it is. You flipped yours and it still worked.
I just did that.
Oh, you went upwards, that's why. It flipped both sides. All right, so using the equation here, we're going to use the equation for this one. Okay. Mike, what would you plug into the top of the equation?
Wait, alright, which way are you doing?
The bottom. Right.
-8
Yep.
plus 10.
Not plus
We're not
10.
even counting 10.
What'd you say? -8
Minus 10.
minus 10. Okay, good. So that's your y's. And then on the bottom there, Josh, what would you put on the bottom? So it says x2 minus x1. Where's your x2? What were you about to say? Where's x2? Which one has an x2 above it? Okay, so you do 6 minus what? What's not 8. You need to go x2 minus x1. So which one is x1?
Oh, -4.
So 6 minus a -4. Getting it there? So that's negative 18, and then that becomes plus, so that'd be 6 plus 4. So that's negative 18 over. What goes into both negative 18 and 10? 2 would be a better choice, yes. All right. So, what questions you guys have on finding slope from tables and points? Mike.
Can you do the other way?
The stacking? Yeah, that's fine. I'm just showing you guys the equation too, so you guys know where the stacking comes from. Whichever way makes most sense to you. That's why I show you guys multiple ways to do things. Nope, not yet. Good question though. All right. So we have the slopes of vertical and horizontal lines. If you look at this one, you're rising 0 and you're running 1. So you rise 0, run 1. So that's the rise over run of
0.
Okay, if you have your calculator out, do 0 divided by 1 in your calculator.
0.
Do 0, just do it. I know this seems...
It's 0.
It's 0, yes. So this slope is 0. Do not write down the word 0 slope, ever. This slope is 0. If you'd use 2 points, if I chose the points 0, 2, and 1, 2, and I found the slope, I would do 2 minus 2 over 1 minus 0, and I would get 0 over 1, which is just 0. Okay? Either way, that's how that would work. So a horizontal line always has a slope of 0. It's a 0 grade. So if you think about it, have you guys ever seen like it has like a 25% grade and it has like, have you guys ever been in the mountains where there's like trucks, like truck passes that they can go into?
Yeah.
Because they can't stop very easy. This has a 0 grade, which means it's just a flat surface, easy to drive on. Which makes sense. If it's a horizontal line, you can walk across that line, right? Yeah. Okay, well this one is rising up 1 and running 0. So that's 1 over 0. Put 1 over 0 in your calculator and tell me what happens. No.
Divided by 0 error.
Thank you. It says divided by 0 error. You may not divide by 0. You are not allowed to divide by 0. This is known as undefined.
Oh, I should have known that.
There is no slope for a vertical line. Can you walk up a vertical line?
Yes. If you're Spider-Man.
I was gonna say.
Okay, you, Riley, are not Spider-Man. Can you walk up the line?
Thanks for ruining my dream.
So anyways, it is not possible to walk this line. It is undefined, okay? There is no slope for this. So it is okay to divide by 0. To divide by on top, but it is not okay to have 0 on the bottom. So, okay, 0 can be on top, but it is not allowed to have it on bottom. That's what that says. So, a vertical line has an undefined slope. So a vertical line always has an undefined slope. So go ahead and write that stuff down, and then we just have 2 more pages, and then we are done. So we're going to, 2 more slides. One of them is just a concept review, though.
What is concept?
Guys, that doesn't mean we're done. Please stop talking. Okay. Are you good? Okay. So, let's review our concept. A positive slope will always go uphill left to right. So you read like you read a book. So you know the slope should be positive if it's going uphill left to right. You're walking up a hill. If a little man was walking up this from left to right, he'd be going upwards, right?
Spider-Man.
Spider-Man doesn't need this. You can do this.
No, that is way too steep.
That's way too steep.
Downhill from left to right is negative.
I'll roll down this.
You'll just roll.
Yeah, I'll roll down this. Right.
That seems like you'd like break a couple of
It would still be fun. Either which I get hurt.
It'd be fun until I broke my leg.
All right, so downhill from left to right. Shh. Downhill from left to right is a negative slope. Do you guys have a random line on yours that I don't
That's
have?
how it was for this one. We had 2 arrows.
That's weird. Interesting.
Oh, whoa, what?
I
think I did the wrong one then.
No, you didn't. All right. So a zero slope is always a horizontal line. And an undefined slope is always a vertical line. And then we're going to get to that last example. So go ahead and get that down. Make sure you're making your slopes negative when they're negative and positive when they're positive. Make sure you're always doing y over x. Please. Is that an ostrich on your pop socket?
That's both mine. I have an obsession with that one.
Interesting. All right. Stop it. It's not a question to be asking. All right. This is a hard concept for you guys, so focus. Focus. Up here. Up here. Hard concept. All right. So find the rate of change from these domains. So these are domains, which means they are an x value to an x value. I've been kind of writing it up this way the whole time to get you guys used to it. So this is x to an x, which creates 2 ordered pairs. So an x to an x. So your ordered pair is 0, comma something and 5, comma something. What is that something? What is that something? What is it? 0, comma 0 and 5, comma 10. So when you do the slope, it's y2 minus y1 over x2 minus x1. Or you can do the stacking. I don't really care how you do it. So that's 10 minus 0 over 5 minus 0, which is 10 over 5, which is 2. But there's units on this. There are units on this. What does the y represent? Position in meters, it looks like. So these are the meters. And what does the x represent? Minutes. So that's 2 meters per minute. Okay, again, this is another x value to another x value. So that's 15, comma something and 20, comma something. What should go into the 15, comma something spot? Miguel, what goes 15, comma what? 15, comma 10. Shh. Brian, 20, comma what? 20, comma what? 60. So, again, shh. We know it is meters per minute when we get to our answer. And you do your subtraction. So we have x1, y1, x2, y2. So that's 60 minus 10 over 20 minus 15, which is 50 over 5, which is 10. What are the units?
10 meters per minute.
If there are units, you must put them on there. On your quiz on Friday, if you don't put the units, you're going to lose points. Yeah, I did say that already. This is not the first time I'm saying it this period, so we're aware. Oh, yeah, I'm positive. Don't worry, guys. All right, so we have an x value to another x value here. So we have 30, comma something and 35, comma something. So Grace, 30 comma what? 60, good. So it's 30 comma 60. And Blaine, 35 comma. Okay, again, your slope is y2 minus y1 over x2 minus x1. And we know that it's meters as our x and minutes for our, meters for our y, minutes for our x. So we do 10 minus 60 over 35 minus 30, which is negative 50 over 5, which is negative 10 meters per minute. So they're slowing down. And then finally, this last one here, again, it's another x value to an x value. So it would be 35 comma something and 40 comma something. Bless you. Jordan, it's 35 comma 10, good. And Mike, 40 comma 0. So m is y2 minus y1 over x2 minus x1. Or you can do the stackable if you want to do it that way. I'm fine with that. So that would be 0 minus 10 over 40 minus 35, which is negative 10 over 5, which is negative 2. But what are my units? Meters per minute. Okay. So, questions on this before we answer the question? Answer the question down there, number 2. Do you guys understand that those are intervals? They're not ordered pairs.
Correct.
This is over a domain. So this is an x value to another x value. You must create the ordered pairs. Do you guys all see that?
That would be politically correct.
Which interval has the greatest rate of change? Yeah. B, you can see that, but there's one more that has the same rate of change. Which one has the same rate of change? So is there one that has a greater rate of change necessarily?
No.
Does it matter that one's negative and one's positive?
No.
It's still changing by the same amount, right?
Yeah.
So they have the same steepness. One's just positive, one's negative. So technically, it's 15 to 20 and 30 to 35 are changing by the most. They still have the same steepness. One's just positive and one's just negative. So the negativity does not matter. Okay.